Hey everybody, my name is Martin, and this is a video series to give you a tutorial on assembly language with RISC-V. We're going to do just some very basic stuff to get you going with assembly language, and I've cut this up into a number of different videos so that way you can just go to the videos if you kind of have to stop and come back. Make it easy to keep going from where you started. This is just the introduction to give you an idea of what we're going to be doing and how we're going to be doing it, and so let's get going. So basically what we're going to be doing is building a small project. You'll see I call it Super Blink, where we're just going to blink some LEDs on a microcontroller board. So for this video, I'm kind of assuming that you have a little bit of experience doing stuff with microcontrollers like Arduino, ST Micro, Espressif, and those kinds of controller boards, and that you've got some software development experience. So if you're completely new to programming microcontrollers, or you're completely new to programming, this is probably not the best video to get started. But assuming you've got some of that background, this is how we're going to get started. So we're going to use Visual Studio Code, which is a text editor that allows us to do all of our actual code development. Now, I'm not going to give you a tutorial on Visual Studio Code. If you're new to Visual Studio Code, you should probably stop here. There's a whole bunch of videos on YouTube that'll get you going. If you really want to, you can actually use an alternate editor. There's probably 10 different kinds you can use, but this tutorial is built around Visual Studio Code and uses some of the features like debugging, etc., that are there. Now we're going to use an extension to Visual Studio Code called PlatformIO, and actually that's where really all the power of development comes here, is from PlatformIO, because it is a tool that allows you to develop for almost any microcontroller you can think of, any platform you can think of, any library you can think of. They're pretty much all well integrated into PlatformIO, and you are going to see that. So I am going to go through and show you how to install and how to use PlatformIO, but only with Visual Studio Code. One of the things you'll find out here is PlatformIO can actually integrate into almost any IDE you can think of. So if you prefer using Atom or Sublime Text or Eclipse or any other cloud IDE, the odds are that PlatformIO can integrate in. And so if you really want to do that, you can go ahead and do it that way. Again, for this tutorial, we're going to focus on PlatformIO as an extension to Visual Studio Code. Now, in order to write RISC-V assembly, we need a RISC-V board. And we're going to use a board from a company called SiFive. You can go to SiFive.com, find out more there. And they build a cool little board called HiFive1, which you can see on the screen. And the HiFive1 is a Arduino format. So the Arduino makes these hardware formats called R3, if I remember correctly. And this is an R3 formatted or form factor board that has a RISC-V processor, and that's what we're going to use in order to build our first round of assembly language. Now we're going to go through and I'm going to show you how to integrate some documentation that we're going to use, but just as a mode of background, if you're completely new to RISC-V, RISC-V is an open source instruction set architecture. I wanted to point you to some resources that you can go look at in order to learn more about RISC-V. So the first two are books that you can get either in paperback or hardcover, I can't remember which, but you can get printed copies of these books from Amazon, and I think both of them also have digital copies, so you can get them for your Kindle or what have you. Those will go into the depths of computer architecture, and the interesting thing is that they use RISC-V as their foundation to talk through computer architecture. So in some ways they're not really RISC-V books, but they are books more about learning how computer architecture is done, and they just happen to use RISC-V as the foundational instruction set to help you learn that. The third book, called the RISC-V Reader, at least at the point at which I'm doing this video, is only available in paper copy. And so I would strongly encourage you, it's not very expensive, you go to Amazon, get your copy, because I do use some stuff from that book, and because it's only a printed copy, I won't be able to show you exactly or copy and paste from it. But you'll have to trust me that the stuff that I'm doing is actually from this book, and so that's why I really would encourage you to get a copy of this book. So what we're going to do in this tutorial is we're going to build something called SuperBlink. And the reason why I call it SuperBlink is that in the microcontroller world, the equivalent of a Hello World application is blink the LED on your microcontroller. And so if you've done any kind of microcontroller development, you'll know that the first thing you do is try to blink the LED, and that just verifies that you've got a hardware connection that works and that your development environment also works. And the reason I call it SuperBlink is we're going to do a couple of things that go beyond the traditional Hello World or just blink the LED. First thing is the HiFive1 board has 3 LEDs, red, green, and blue, and we're going to just blink them in succession. So that's one thing that's going to be a little bit different rather than just blinking one LED. Now, of course, the thing that's about this about this tutorial is it's about RISC-V assembly. So almost everything we're going to do is going to be written in RISC-V assembly, and that's not typical for the microcontroller Hello World type of application. And so in our case, we're going to do most of this in RISC-V assembly. But the other thing I wanted to show you was how you could actually write most of your code in RISC-V assembly, but call it from C code. And so our main routine is really going to be written in C. It's going to be very simple. But in that C code, we're going to call some functions, but those functions are going to be written in an assembly language. And you're going to see through how we do that and how all that comes together. And then the other thing is we're going to use the features of PlatformIO integrated with VS Code or Visual Studio Code in order to actually debug and single step through our assembly language code so that we can actually see what's happening as we go along. Parts of this, of course, happen on the microcontroller board. So I've included a little video here that you should see on the inset that shows you this LED sequence blinking. But that's really simply what we're going to go do. So that's our project. That's what we're going to go do. That's it for the introduction. Get to part 2 and we'll start setting up our environment so that we can do our assembly language development.